Well, I'll be your instructor for Math 140 this term. This is your second lecture, and Josep replaced me the first lecture, and he told me that you started the material, so I'll just continue where he stopped last time. Okay, great. Maybe a few things about the course. I think you can see the course outline, right, on my courses. So I think it's 15% web work, 30% midterm, and 55% final. Okay, so standard way. I recommend that you get your 15% on the web work. You can easily get that. And then the 30% midterm, if you work hard enough, you will do very well on the midterm. And the final also, if you work hard enough, you will do very well on the final. The textbook for this class is Stewart Calculus, 9th edition. One good thing about this class is that the exam questions, the midterm and the final, will all be taken from the book. Okay? So they're going to be taken from the odd numbered exercises in the book. So of course you don't have to do the entire book, but you just have to do enough practice to make sure that you have a good grasp of the material. Okay? And I say that to every single time. I mean, I taught this class 3 times so far, but every single time it seems that people take it very lightly. Please do not take it lightly. Try to work every day. Okay? Do some questions from the book. I can help by assigning some. Say, I recommend these, so it gives you an idea where to start. But the webworks, I don't think they're enough. Okay? Doing only the webworks is not enough. Okay, webwork questions, I think you have in total, in the entire term, you have like maybe 90, at most 90 webwork questions. That's not enough at all. Like if you really rely only on this, then don't be surprised. You won't perform very well, okay? So you have to work independently. And yeah, okay, great. Any more questions? Yeah, yes? The midterm is October 30, right? Something like that? 15, 30? I don't know when it is. But it's in October, so we did not discuss what's going to be on the midterm. But I think there is a version of pre-calc Math 139 that was taught, and then the recordings are available online. So I will post them on my courses. And if you're comfortable with this material, then you should be fine. If you're not, then I invite you to, maybe, well, I don't want to say anything, but I invite you to maybe move to 139. If you're not comfortable with trig, you're not comfortable with inverse functions, logs, I don't know. Yeah, okay? Logs, exponentials, trig, functions, vertical test, vertical line test, and things like that. If you're not comfortable with these, 139 is the course you should be in, okay? Because we won't recap that. We will just use it, okay? Any more questions? Great. So, yeah, I mean, there may be 500 students here, so I may not, so please say something. Yes?
So for the web work, would they appear around what time? How much time do we have to complete them?
Very reasonable. It's very reasonable. Okay? Don't worry about it. Okay? We're still the first week. Okay? So it's going to be very reasonable. You'll have time to complete it. Okay?
I'm just asking, like, would they appear like on Monday, Tuesday, Tuesday?
So questions of this nature should be addressed to the course coordinator. Okay? Like I think he's the one who assigns the work. Okay?
Sorry, I'm really.
No, that's fine. I mean, it's one less, it's one less thing for me to do. So I'm not in charge of this. Okay? But yeah. So if you have any questions on the midterm web work, you can ask Professor Sidney Trudeau. I think he's in charge of this, so he will happily answer. But again, it's going to be 6 web works. Each web work is roughly 12 questions, 12, 15 questions. So it's going to be very reasonable. And you have infinite attempts. You're allowed infinite attempts. So you can like mess it up as many times as you want. Okay? But again, don't worry about it. Okay? It's going to be an easy 15% if you do it. Okay? Great. Okay, so let's continue. So you guys have started one-sided limit, right? One-sided limit last time. Yeah? Okay. But I think, don't you have access to the web work through my courses? If you click on my courses, don't you have access to web work? Yeah, okay. Do they appear all or not yet? They appear all? Web work 1 up to web work 6 or 7? Yeah. And then the dates of release, do they appear or not yet? No? Okay. That's fine. That's fine. It's not a problem. We'll worry about that later. We're still in the second day of class. Okay. So let F be a function defined on an open interval containing A except at possibly A. We write L if we can make the values of f of x arbitrarily close L by making it sufficient close to A with what? Who can help here? Yeah. Without being A, that's one condition, but I'm going here to A plus, right? Did you see that notation on Wednesday? What does A plus mean? This is A. Here, right? So what can I say about X here? It's not equal to A, but it is, yeah, someone said, exactly, with X strictly greater than A. I mean, I will write this A minus, blah, 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 with X strictly, what do I have to add here? Smaller or less than A. Okay, great. So let's do an example here. So I have a function y is equal f of x, and this is the point x equals 0. What is f of 0? F of 0, I have a dot, well, I think it's that this is 2 here and this is 2, and let's put the dot. This is 1. What is f of 0? 1. Okay. What is the limit as x approaches 0 minus of f of x? 2. Awesome. So let me change that here to 3. What is the limit as x approaches 0 plus of x? Negative 3. Now, what can I say about the limit as x approaches 0 f of x? Does it exist or not? No. Very good. write that somewhere. Does not exist. Awesome. Okay. So in general, plugging in f of 0 for the limit does not work, right? You cannot just plug in, right? You see that? Okay. Any questions thus far? Are we all good here? Yeah? Great. Awesome. Now we have an important theorem. Is equal to L if and only if I think you saw this, but you did not try this last time. So L is a real number. L is a number. L is a real. Okay? So you saw that the limit as x approaches a of f of x is equal to L if and only if these two-sided limits are both equal to L. Right? Right. Here, well, if these two limits are different, then the limit at x equals 0 does not exist. Just saying 0. You have to take a direction, either from the positive, from greater than 0, or smaller than 0. Are we all good so far? Everyone? Yeah? Awesome. Any questions? Please do not hesitate to ask questions. Yes?
When we have to find f of n of x, for example, here 0,
Yeah.
shouldn't be the answer it comes from the curve?
Yeah, the curve.
Like one is not on the curve.
One is not on the, well, but what, are you assuming that you can do the curve without, you can remove your hand while tracing the curve? Yeah? So, I don't know, let's try, f of x, let's give an example here. F of x is 0 if x is less than 0, right? And f of x is 1 if x is strictly bigger than 0. And let's say f of x is 1/2 if x is equal to 0. That's the function, do you agree? Goes like that. 0, add 0 is 1/2, and then it's 1. So this point is on the curve. Okay? Just the curve is not continuous. You have to lift your hand. You have to lift your pen when you're drawing it. Is that good? Okay. Where's the... Okay? Great. Now let's do an example. Should we do an example? Let's do examples like that. I don't know. Okay? Can we draw this or not? Do we know how to draw this curve, this function? So I have function f. It's x if x is less or equal to 0. Here I am, right? The line y equal x when x is less or equal to 0. So far so good. Yeah or no? Now, between 0 and 1, it's equal to x plus 1. I draw the line y equal x plus 1. Now, what is f of 0? If I want to calculate f of 0, do I use this one or this one? Or the top one, right? Because x is less or equal to 0. Are we agreed? Less than or equal to 0. So I'll put here, and then I'll put an open circle here. And then I have x squared if x is bigger than 1. So this is x plus 1 here. So here, 1, how do I compute f of 1? With this one or this one? Top or bottom? Top, right? Now, it's x squared if x is bigger than 1, so here. Do you agree? Yeah? What is, well, you agree with this? Everybody, we agree with this? Yeah? I'm gonna ask someone to give me their favorite number. 7. So what's the limit as x approaches minus 7 of f of x? When you're at minus 7, you're here, right? If x is approaching minus 7, where does f of x tend to? Minus 7, right? And what is f of minus 7 here? It's also minus 7, right? You agree? It's a coincidence. Cool. Great. Now, what is the limit as x approaches 0 plus of f of x? So, x is 0 plus. Where is f of x? X is going to 0 plus. F of x gets arbitrarily close to. You can make f of x arbitrarily close to 1, right? By making x sufficiently close to a, while sufficiently close to 0 while being strictly greater than 0, right? Great. What's the limit as x goes to 0 minus? What is that? 0. What can I say about the limit as x approaches 0 of f of x? Does not exist. Awesome. Great. Okay. Well, what's the limit as x approaches 1 plus of f of x? 1, right? If x is bigger than 1, what is f of x? X squared, right? Do you agree or not? You see that? Great. And what is the limit as x approaches 1 minus of f of x? 2. We agree? Awesome. So far, so good. Yeah? Yes?
In the second, in B, it's 1, but it says doesn't include the half of the,
Here?
yeah.
Here it does. Here it includes 1. But here it doesn't.
It doesn't include 0, you can see it's an open circle 0.
Oh, here you mean? Yeah, here it doesn't include 0. Here it does.
So that why does it include
The open circle means it doesn't include it. The full circle means it includes. Okay? So just annotate it. Okay, you can get arbitrary close to 0, the x values, but it's not 0. Okay? I mean, how can you show? You have to put an x or something like that. Okay? Great. Awesome. Are we good now? A. Yes? Guys, yeah? Okay, so what is the value of x plus 1 at x equal 1? 2. What is the value of x squared at x equal 1? 1. Do they connect? One goes up, and then one starts from... They both go up, but they start from different points, and they go up in different ways. Okay? Yeah? Great. Awesome. So now that this is clear, how many of you have seen derivatives, limit derivatives before? Oh, whoa, okay. That's 90% maybe of the class, if not more. Great. Awesome. But, again, everybody, do not take this lightly, okay? Don't say don't count on your previous knowledge to tackle this course. Just work as if you were seeing this for the first time. Okay, great, awesome. Now we're going to talk about infinite limits. Okay, so suppose I have y is equal to 1 over x. We all know how to sketch the hyperbola, right? Y is equal 1 over x. Now, when I ask you to say, what is the limit? I ask you to describe the behavior of the function, y is equal 1 over x. Let's draw a box. If x, let's say, is positive and close to 0. So if x is going to 0 plus, what happens to 1 over x? So what is 1 over 1 half? 1 over 0.5 is 2. What's 1 over 1/3? 3. What's 1 over 1/4? What's 1 over 100? So 1 over 0.01. It's 100, right? 1 over 0.001. 1,000. 1 over 0.0001. Million, 10,000, I don't know what it is. Okay? How many zeros? You just, right? Now, what can you say about 1 over x? Does it get close, can you make it arbitrary close to a number, to a finite number? No. But does it behave in a, so the limit as x goes to 0 plus, so 1 over x, doesn't exist. That's clear. But can I give it a better description? Can you make 1 over x arbitrarily large, positive, by taking x sufficiently close to a? So if I tell you I want 1 over x to be larger than 1,000,000, right? X has to be smaller than what? So if 1 over x, I want this to be 10 to the 6, bigger than 10 to the 6. X should be less than 10 to the minus 6, right? You agree with this? Now if I tell you I want 1 over x to be bigger than, I don't know, 2 times 10 to the 235, which is a very large number. Can you make x, can you choose such an x to make this valid? So what do you do? Right? You agree? So can you make f of x arbitrarily large and positive here? 1 over x, you can make it arbitrarily large by taking values of x that are strictly positive, but sufficiently close to 0. You agree? Are we good? Awesome. So let's write this down. So if you were to guess, what's something, well, I don't want to say, what's a word we use to describe a positive large thing? Infinity. So what can we say about this? Sure, this limit does not exist. But as x goes to 0 plus of 1 over x, what is that? Plus infinity. You agree? Yeah? And what is the limit as x goes to 0 minus? Minus infinity, because you can make the values of f of x large but negative, right? Large in magnitude, but with a negative sign. You agree? By making x sufficiently close to 0 while being strictly less than 0. Are we all good with this? Okay, great. So let's write this down. Let's write a formal definition of this. So of course, f is defined on interval. Well, f is defined on an interval, on an open interval containing a, but possibly not f. Okay, we write the limit x approaches a of f of x is equal plus infinity. If we can make the values of f of x arbitrarily large positive by taking x sufficiently close to A. Did I miss anything? Is there anything wrong here? Read the first sentence. F is defined on an open interval containing A, but possibly not at A. Okay, did I miss anything here? X by taking X sufficiently close to A, but not equal to A. Okay, and then the definitions. Of course, well, the definition of limit x to A plus x to minus of f of x is equal plus infinity or minus infinity, and are left as an exercise, okay? Okay, I mean, it's the same thing. If x approaches A plus, and the limit as x approaches A plus of f of x is plus infinity, if we can make the values of f of x arbitrarily large positive by taking f sufficiently close to A with x strictly bigger than A, right? Now, if I want the limit as x goes to A plus of f of x equal minus infinity, blah, 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 if we can make the values of f of x arbitrarily large negative, right? Large in magnitude, but negative in values. By guys, yes?
Can you please read out the second line?
Yeah. Where? Here?
The very last thing you wrote.
Here?
No,
The last thing.
on the other whiteboard.
Oh, the definitions of limit x approaches A plus or x approaches A minus f of x equal plus or infinity or minus infinity are left as an exercise. Okay, great. Awesome. Let's do an example. Yeah? Any questions? Yes, sir. What? An exercise. You do it on your own, basically. Okay? You do it on your own. Anybody majoring in math or not? Anyone majoring in math? Yeah. Is left as an exercise is a sentence you will encounter in your entire major. Okay? Okay, great. It's usually it's a big theorem, and then it says the proof is obvious and is left as an exercise. But yeah. Anyway, so let's give an example. Okay, great. This is f of x. Yeah, let's say this is 2. What is f of 1? F of 1, this is x equal 1 here. And this is x equals 0. F of 1 is 2. Awesome. What is the limit as x approaches 0 plus of f of x? Minus infinity, right? Is f of 0 defined? Did I define f of 0? F of 0 is not defined. F is not defined as 0. the limit as x approaches 0 minus? It's plus x. Okay, what is the limit as x? Let's write this. Am I going a bit fast or? I see. Okay, that's fine. That's fine. So, I can tell you something. I'm going a bit fast at the beginning to go a bit slower at the end. The end where it gets way harder. So, okay, guys. Hey. Yes. Yes. Consider. Okay, great. Awesome. Okay, any more questions? Yes.
Would you mind
Speaking a bit louder, sure. I wouldn't mind. That's yeah. I won't. Yeah. Sure. Yes. I will post off. Yeah, I think I should set. Yeah. I have office hours. Yes. Would you please repeat?
I can't see the numbers when you put them on the axis, so I can't see the graph.
Here, now, or in general? Okay. Okay, I'll try my best to. I mean, it's a big room. Yes. Any more questions? Okay, guys. Great. What time is it? Okay. Still have 20 minutes left. Questions? We good? Okay. So I'll try to speak a bit louder. What did I say? X goes to 1 plus f of x. Okay. Great. Awesome. Any questions on this stuff? Yeah?
Can you explain why the limit for x approaches 1 to the right of 2?
1. Oh. Look at here. Okay? X is going to 1 plus. Can you make f of x arbitrarily close to 2 if x, while making x sufficiently close to 1? Yeah? You're here. Yeah? Great. Any questions? Awesome. Pardon me? Yeah?
So is it the limit does not exist in going to infinity?
Yeah, so when the limit is infinite, it does not exist, but we will write it's infinity. Okay?
The same for both sides. It doesn't exist.
It doesn't exist, but we write infinity. Okay? So for example, that's a good question. This is the graph of y is equal to 1 over x squared. The limit as x goes to 0 of 1 over x squared is plus infinity. Okay? Yeah? Okay, great. Awesome. Now let us try to calculate some of these limits. I mean, you know, okay, so let us try to. Okay, guys, everybody. Questions? Awesome. Okay. So far, so good? Yeah? You had a question? No? Okay. Yeah?
Would you be able to use the second set of words so people
Oh,
who
this
write
one.
lower can copy? Sorry.
Okay. That's okay. Yeah, sure.
Thank you.
Okay. Awesome. Now let's try to calculate some limits. Now, usually when you say 1 over x, okay, and you tried x to be 0 plus, right? X is approaching 0 plus. What's the thing you did? What's the thing we did? How did we say this is infinity? Sure. So what we did is that we did something very intuitive, and I took very small values of x that are positive, and I plugged them in 1 over x, right? And then we notice that these values are getting close to 0. You agree? Now 1 over 0, can we do this? Can you do 1 over 0? But you know that 1 over 0, or 1 over a small positive number, is a very large positive number, right? This is how we determine this. You agree or not? Okay, so let us try to evaluate the following limit. This is not, maybe you may not have the tools right now, but you have to rely on your intuition, okay? Let's say 5 plus of x plus 1 over x minus 5. Evaluate the infinity. Okay, I mean, we'll revisit this, but this is just a small exercise just to see how to think. Now, if x is approaching 5 plus, where does x plus 1 go to? 6, right? You agree? Everybody, you agree? Yes. Now, the bottom, the denominator, where does it go? 0. Now, you would say, okay, it's approaching 6. Let's say it was approaching 2, you would divide 6 by 2. Right? That's an intuition. So you get 3. But here, can you divide by 0? No. Okay, so there is something happening, right? Now, what can I say about x minus 5? So I have a 6 over 0. You agree? Yeah. Which is a bit, it's not a number. It's not a real number. Now, what can you say about this 0? X minus 5 is approaching 5 plus. Does x minus 5 stay positive or negative? Positive. You see that? So what do you expect the limit to be here? Plus infinity. Okay? You guys see this? Do we all see this? Okay, this is just for us to have an idea on how we will proceed in this course. This is the way to think. Okay? Any questions? Awesome. Great. Let's do something. Okay. Let's do an example from the book. Or introduce limit laws. Okay. This is 1. Let's see, 4 minus x minus 4. How to think with this? So 3 minus x, if x is approaching 4 minus, where does 3 minus x go to? Minus 1. So the top is negative 1. Okay, the bottom, x minus 4, what is that? If x is approaching 4 minus? 0. You agree? Everybody, do we agree? Yes. Okay, now if x is less than 4, what can you say about x minus 4? Is it positive or negative? Negative. So I have a 0 that is negative, right? And here what do you have? Negative 1, right? Negative 1 over a 0 that is negative, what is that? Positive. infinity. You agree or not?
Yes.
Everybody?
Yes.
100%?
Yes.
Great, awesome. Okay? Yes?
But so when you define that 0 is negative, it's because
Guys.
x approaches 4 minus?
Exactly.
Okay.
X is 4 minus means that X is approaching 4, right? But X is strictly less than 4.
Okay.
If X is strictly less than 4, what can you say about X minus 4? It's negative, right? And how do you establish that? What's one way to establish that? Now it doesn't always work, but in our cases, it's safe to assume that it works. Give me a number that is close to 4, but close to 4, but strictly smaller than 4. 399, let's say. Plug in 399 minus 4. What do you get? Negative 0.01, right? So you get an idea that it's a negative number. Are we all good here? Okay, great. I think that's fine. I mean, let's do one more here. Or you know what? Let's spice it up a bit. And put the absolute values. Okay. What is the top in this case? 1. Agree? So I have a positive. Now, what is the limit as x approaches 1 of the absolute value of x minus 1? 0. You agree or not? Now, is it a positive 0 or a negative 0? Can you determine whether it's positive or negative? It's positive, right? The absolute value is always positive. So what is this limit? Plus infinity. Okay? Are we all good? Is it clear?
Yes.
Awesome. No, I forgot which is the good one. This is the good one? Yeah. I think let's put it aside. Okay. Now, let's start with a definition, another definition. Or, you know, let's establish some limit rules. Okay? These are very important. These are called the limit laws. And these are the set of rules, or these are the set of, this is a set of rules that we will be using throughout. Okay. Maybe let's motivate this. What is the limit as x approaches 1 of x squared? 1, you agree? Draw the curve y equal x squared. Can you make x squared arbitrarily close to 1 by making x sufficiently close to but not equal to 1? Yes. Okay. I don't know. Of x plus 2. Right? Take the line y equal x plus 2. As x approaches 1, what is this limit? 3. Now, what is the limit of x squared plus x plus 2 as x approaches 1? X squared plus x plus 2. What is that? Yes, someone said it? 4. How did I do this? You can still make x sufficiently close to 1 and f of x arbitrarily close to 4 by taking x sufficiently close to 1, right, but not equal to 1. But you can also add these two results. Once you add them, what do you get? 4. Okay, now these are the limit rules. Okay, I promise I will Yeah, so let's see. Gal, oh. Yeah. Yeah, but this one, okay, it doesn't work, I guess. Yeah, I have to throw it.
Yep, throw it.
Yeah, but I may break it, like. Yeah, no, I won't do it. I think it happened once, and then you had two ropes, right? And one of the ropes broke, so, yeah, I won't do it, I'll do this one. I mean, I've been, told by someone who felt in this room that, yeah, anyways. Great, let's do it, so let F and G be functions defined on an open interval containing A except at possibly A and suppose that the limit as x approaches A of f of x is equal to L and the limit as x approaches A of g of x is equal to L prime. Then, so that's fine. Then, what can I say? Do I have another one? No way, what happened? Why did I open? Oh, that's good. Is that good? Yeah, okay. Then, what do you expect it to be? If f of x, the limit of f of x is L, and the limit of g of x is L, both as x approach A, what do you expect that to be? L plus, oh, it's L and L prime, sorry, it's L plus L prime. Now, what is this limit? F times g. It's L times L prime. You agree? Now, what is f over g? What is that? L over L prime. Do you have to pay attention for something? Provided L prime is non-zero. If L prime is equal to 0, we may have to do something different. Okay? If C is a constant, what is the limit as x approaches A of C f of x? C times L, right? So far so good. Okay, let's do one more. What time is it? 23, I have 2 more minutes. What's the limit? Towards of x, what is that? A, right? If x approaches A, right? What is the limit as x approaches A of x? A. Now, if n is a positive integer, What's the limit as x approaches a of x to the n? A to the n. You all agree? Yep. Now, if f of x is a polynomial, do you all know what a polynomial is? If f of x is a polynomial, what is the limit as x approaches a of f of x? So let's say, for example, x squared plus 2x plus 5 as x approaches 1. Combine all of these rules. X squared, if x approaches 1, where does x squared approach? Where does x squared tend to? 1. 2x, 2. And 5, 5. So it's 1 plus 2 plus 5. This is just f of 1, right? You agree? You can just plug in 1 here if you have a polynomial. Okay, that's it for today, and see you on Monday.